Good day! For today's video, I am going to demonstrate the principle of Gay-Lussac's law. It states that the temperature and pressure of an ideal gas are directly proportional. This means that as temperature increases, the pressure increases as well, and vice versa. The materials needed are the following: a shallow dish, some water with food coloring, a candlestick, some matches, and a jar.
The candle is placed at the center of the dish. Next, light up the candle with a matchstick. Next, fill the shallow dish with 1 inch or 2 of water with coloring for it to become easier to see. And lastly, take the glass jar, placing it over the top of the candle. After how many seconds, while having our jar over the candle, you will notice that the candle's flame gets smaller and smaller until it is extinguished. Also, you will see that the water level underneath the jar begins to rise after the light from the candle has been fully extinguished. The water outside the jar is lower than the water inside the jar. Now for the question, how was the Gay-Lussac's law applied in the experiment? Gay-Lussac's law states that the temperature of an ideal gas is directly proportional to the pressure it exerts on its container, as long as its volume and mass remain constant within a closed system. The jar is placed over the candle and the flame heats the air up. So when the air is heated, the gas particles expand and more faster, putting pressure on the water that has a higher temperature. This is equal to higher air pressure, and that is stated in the Gay-Lussac's law, where pressure increases proportionately to temperature increase. Carbon dioxide is a product from the chemical reaction that pushes oxygen downwards, since it is hotter. And as more carbon dioxide is produced, there is less oxygen available for the combustion, causing the flame to go out. This lowers the temperature of the air, and applying Gay-Lussac's law, now there is lesser pressure on the water, and the decrease in air pressure causes the water to rise. This shows the direct relationship of pressure and temperature.
Yay!
Arrow to the heart. I never kissed a mouth that tastes like yours. Strawberries and a